Yep. Thank you so much for that presentation. It was very great hearing what you had to share about DAOPS Foundation and how, of course, the company itself is the organization itself is trying to develop the next generation software engineering infrastructure, and of course, for explaining how SM helps global enterprises build a high performance technical organization. So we'll be taking a quick break and then we'll be moving on to our next session, which is waiting for our next speaker to get ready. So just kindly stay tuned and we will resume again in a couple of minutes. Yes, hi everybody. Welcome back to the DAOPS Foundation meetup. Sorry, it took quite a while to get the speaker ready, and I hope you did take some insights from our last session, which was hosted by Mr. Forrest Jing from the DAOPS Foundation. So as of right now, we will be moving on to our next presentation, and I would like to call on Mr. Bart from the TARS Foundation. So TARS is a high-performance RPC framework based on name service and TARS protocol. So it integrated administration platform and implemented hosting services via a flexible schedule. So Bart's topic will be about, of course, the new generation of microservices ecosystem. So I will hand the stage over to you, Bart.
Okay, thank you. This is Bart from TARS Foundation and a team member from Mark. And today I will take his place to give us this speech. So let's start. Uh, Before we talk about the TARS project itself, let's talk about Linux. Today, everyone knows today's Linux Foundation is much more than Linux. And TARS is uh, established as the TARS framework, TARS Foundation last year, and joined the Linux Foundation's umbrella. And you can see here, and TARS Foundation is one of the foundation in the domain of microservices. And today, Linux Foundation has several domains of all the technology like security, networking, cloud, microservices, and automotive, blockchain, edge, and web. Yeah, and as we know, the Linux Foundation is not just Linux, and it's an open source ecosystem. As the TARS is like the same. It is not just the TARS project itself, and this TARS Foundation is going to be a microservice ecosystem. Then let's take a quick stare about the TARS Foundation. TARS Foundation, for now, we take it as a neutral home for open source microservices project that empower any industry to quickly turn idea into applications at scale. And task characteristics that solves microservices for problems, such like agile development with DevOps best practices, and building comprehensive services governance, and multiple language supported, and high performance with scalability. For now, TARS Foundation has more than seven founding members. This is the old data, and I haven't updated yet. For now, we will have 10 members, including several colleges, and more than 30 projects in the TARS Foundation, and more than 12,000 active developers are using TARS, and more than 100 companies in different industries, like from the edge and the esports, fintech, streaming, e-commerce, entertainment, telecommunication, education, and so on. And there are more than 300 contributors via the community. They are from different countries and different companies. They are all from ARM, Tencent, Google, Microservice, Microsoft, VMware, WeBank, TAL, China Literature, iFlyTech, Learn2 Game, and so on. Yeah, let me give you a quick introduce about the TARS and the TARS framework, and it's the microservice ecosystem. From the bottom to the top, TARS includes includes infrastructure. It means TARS can run on a physical machine or virtual machine or container or on the Kubernetes. And for the storage, TARS can store the data in the memory cache, something like the cache system, the database, and the file system. For the part of the service governance, TARS has the main technology of TARS is the RPC, and it has several core methods like the sync, the async, and the one-way request. And for the protocol, TARS support multiple kind of protocols, like the TARS protocol itself. And for security, it has SSL. And for HTTP, it supports HTTP1 and HTTP2. And TUP is one of the TARS protocol to suit that the application who didn't code by the TARS itself, and it also support the protocol buffers, and which I didn't mention here. It has it supports that the user definition protocol header. And for the service governance, it has several service governance functions, like the naming service, service registry and discovery, and the load balance, the service configuration and the custom monitoring, the metric monitor, the overload protection, the fuzzing, and IDC set module, and distributing tracing, area participation, and logs. Yeah, for the application on TARS, it can support application from edge and big data or deep learning or the API gateway or so on. TARS supports multiple languages. It supports like C++ and Java and Node.js, PHP, Go. And for Python, it supports the client version, but the service version we are still working on that, and the .NET version 2, and we are still working on that. And TARS, it can integrate multiple DevOps tools. Contains the code management, continuous integration, continuous delivery, and continuous deployment. Yeah, this is the quick introduction of the TARS framework. And TARS Foundation has a greenhouse to hold a lot of incubating projects. We can take a look at it. Has the TARS lab, which contains several tools for the benchmark or like the benchmark or based on the JMeter to test the application of TARS. And it has other tools to edit, like TARS tools to edit the TARS files, and TARS Java tools. And it has an open testing lab to set different kind of project working on the testing distribution. And for the platform itself, TARS has the TARS framework. It's the main project of TARS, and TCR is a light way of naming space, and TARS log and monitor and gateway. As the name of it, they are used for the log and monitor and the API gateway. And for the storage and protocol, we have several projects here too. And these two are we just mentioned, but for this one, the cache is it means distribution cache system. It's a cache system based on TARS protocol. And for the infrastructure, TARS can deployment on the Kubernetes, and it can deploy by Docker. Multiple language we just mentioned. We don't take more time here. And TARS has a landscape just like the CNCF, and this is our goal to build our microservice ecosystem. We can take a quick look at it. And this is the timeline of TARS Foundation. TARS starts TARS open sourced in the April 2017, and for the years it continues to develop several functions and support multiple languages. And at the year of 2019, the TARS, 2020, the TARS launched the TARS Foundation, and still TARS is working and growing. Yeah, let's quickly look at. And for now, TARS has has a lot of company and applications using TARS. It shows here, and it contains a lot of different industries area, like the online games or the esports or the online video, and the tools of users I always use, and the entertainment or transportation or social network or fintech and news and reading and e-commerce and edge and internet products and educations. But these are just part of TARS users. Okay, then let's go through the TARS itself. TARS is one microservice framework. For now, we know that different microservice frameworks are focused on different areas. We know the gRPC from Google, it has the perfect RPC framework, but still it don't have the service governance. You should do that yourself. And like the Spring Cloud, it only supports Java. It only supports the single development languages. And the service mesh, it exactly supports multiple languages, but as the sidecar, we think the performance will maybe kind of efficient by the sidecar mode. But TARS, it supports multiple language and governance itself, and we can just take out of the box and to use it. Yeah, the TARS has these four core features. It will provide the basic codes of the RPC, and the developer only need to focus on business logic instead of the base communication codes here. And it has the RPC for agile R&D, and it exactly has high performance, and it can extend, has rich extensions. For the focus on business logic, through the encapsulation, TARS includes transmission and service governance, allowing developer to focus on business logics. It has protocol, it has transmission, it has programming, it has service governance. Like here, TARS protocol is an IDL, and it shared serialization and protocol codec, and it is an interface-oriented programming. You just need an TARS protocol to define all the interface, what you prevent to the others, and others only need to take the TARS protocol to know which interface he can use. Yeah, for the transmission, the encapsulation includes TCP or UDP by configuration, and they can supporting RDMA, Quick, or others by using plugins. And the service governance, it has the service register and service discovery, and it have the load balance function itself, and have the at the same time had the overload protection and distributed tracing. And for programming, now TARS support the future and Promise and the coroutine, and it supply the configuration and metric API. For the RPC for Agile R&D, that achieve rapid business development. The RPC support can be compatibility, high performance, and multiple programming languages, and TARS supports API generation tools. As I just said, the TARS file is something like this. It's basic on C++, based on C++, and it has the structures and the interface. It's easy to understand and to define the function, the interface that you will use. In this in this example, we define the age, the sex, the company, and the hobby of this user. And we have an interface called get user info, and we just to like input the UID file, and we can return all the structure of user info, including these 4 values. Then for the server end, we can deploy the user servant class, and it includes the get user info and just this, and initialize it as 0. And for the client, we can definite the user proxy, and it has the it can call the function get user info. And for the call way, it can has we mentioned 3 ways here, and this use the async way to get user info. It is very easy for develop. So yeah, and for high performance, for different languages, TARS has different ways to do that. For the C++, it has the EPO module and reactor, and it has the asynchronous with the coroutine and the future and promise. For the Java, it has an IO reactor, and it has future and promise. For the Go, it can use the Go routine except and use it as the asynchronous. For the PHP, it used the SWO, and it support the coroutine too. For Node.js, it used the Chrome V8 engine, and it support the future and promise. This is the pressure test results for the high performance of TARS. We use like more than 3 clients to call the server at the same time. And for the server configuration, it supports the Intel Xeon CPU 3.3 GHz, and had 16 gigabytes memory, and had the 1 gigabit network. And here we can see the best is the TARS C++, and the second one is TARS Go, and the third one is TARS Java, and others may be a little lower here. But still, we have higher performance than the Spring Cloud or the gRPC. And for the rich extension, because TARS support multiple protocols, it can support like the HTTP 1 or 2, SSL, the protocol buffers, or user definitions I just mentioned before. For the connection, TARS can connect with outer services who maybe do not developed based on TARS. Here we can support use definition protocols or use TUP, the TARS Uni protocol, to support the outsider connection. And it has the message push. It can extension the message push here for the opens because TARS opens the context of the network, and it can support the user definition of push protocols. And for other com methods, like this is called the one-way request, which is for the situation like the user do not hear the results of the return of the return value, like the traffic or the delay or the timeout, all these metric lists and other statistical information connections. For this situation, we can use one-way request to support that. Then I will introduce about the service governance of TARS itself, how TARS can do the naming service. First, the client is the application who will call the TARS server, and we have a registry here. Registry is the central of the TARS framework. It contains the information of all the TARS servers, and if they are alive or some or other informations. The client first he will ask for the root for server A. We can see server A here, and it has multiple endpoints. And the client send the request to the registry. And before that, the service A endpoints always send the keep alive signal to the TARS node, which on the same machine or the same container. And the node will send the keep alive signal back to the registry every minute. And the registry had all the ends of the server A information, and the client when it will get the server A root, and it asks the registry, and registry gave him back the endpoints of the server A's. Use the RR or hash or wait method to make sure which one or which or some of them will go back to the client. The send back information includes the IP address and the ports and the port information. And when client knows that, and it will continue to call the interfaces. And for the server itself, when it receive the request, and after the reply, it will send all the statistics to the metric and the configuration and the logs and other ticks and the pins to do all the functions of the service governance. And for TARS, it can have the area participation. When we when we do the RPC call, we always have the problem of the large latency in cross IDC call. The automatic area participation through registry and deployment will help us to solve this problem. Like this example we can see here, the client from the area X, we can consume it's the 10.0.1, and it will send the logs to the log servers, and we have 3 log servers here, and 2 of them are in the same area of area X, and the third one is in the different area in the area Y. And when the client want to send logs to those log servers, first it asks the registry about which log server I can send my logs, and registry first find, oh, you are in the area X, you have the IP of 10.0 blah blah blah, and we have two areas of log servers, and the other one is in the area Y, it has 11.0 blah blah. And okay, so I will give back the port list of just in the area X, and then it send back the IP of 10.0.2 .0.2 and 10.0.0.3. These two logic servers back to the client, and client after the client know the exact IP and port, it will send the logs to the right log servers instead of these log server. It is a very simple operation here, and it can definitely reduce the latency and reduce the bandwidth cost, because if these two areas are on like not in the same country, we will cost the bandwidth is very expensive here. And then it will be the stronger disaster tolerance in this function. Then let's introduce about the set mode. Set mode is one of the conception of TARS, and we can build and this set mode through the registry and development framework itself too. At first, I introduce it. What is the set mode? Like this one, we call it set A because it has a logic called the server A, who are calling server B. Maybe like when people log in, it will have the interface and the database of the user informations. We consume it is that. And because the increase of the online users, like we have take an example like one set, like the server A, it can have 1 million online, it can support 1 million online users. And in that, it has the logic of A called B. And if the online users increased from 1 million to 3 million, in the old ways, we should put more 2 server A here and 4 more server B here, and then the server A and server B are calling itself. But in the set mode, we can just scale that directly, like just this is as a set, and we can put it one more set here and one more set here. We have 3 sets to support 3 million online users, and each set didn't affect each other, and it's very easy to do all the scalabilities. It can make the module very it can make this module standard, and it can prevent the feeder diffusion. And it has the efficient operation of massive services. It's very easy to do that. And then TARS has flow control functions. It's built through the registry and development framework too. And how to use that, and the client is this is something like we have the server, we have 2 different endpoints, but for the limit of the for the limit of the resource, maybe this machine or this server here has higher performance because such as like a better CPU or memory, and for this one maybe it has not that good CPU and memories. So we decide, but we do not have more machines here to support to support the requests. So we can set the 10% flow on this server, this endpoint. And when we set this information, the client here it want to request the server, it can automatically to let the server 90% flow here to this server, and the only 10% here to this server, and it will solve the problem of lossless and canary releases. And TARS has the service configuration functions here, and it can make you easy to use configuration with one line of code and the visualization, just like add config in your code. Just import the file name here. And for the configuration module, we have the 4 levels here. They are node config and service config and set config and app or references config here, and we can see all these type configurations on the dashboard of the TARS web. And for each endpoint, we will merge all these 4 levels of configurations here merge that all together to configure just one endpoint. But if we do not need that, we can only use one configuration to the server itself, no matter how many endpoints it has. And how to use TARS, and it's a very easy way to use that. We have like 3 steps here to deploy the TARS the TARS applications. Step 1 is to develop the server end. At first, we should define the interface of TARS file, and then use the shell scripts to build server. The build server is automatic, and then we should inherit the interface, the class and code. We have all these basic we have all the basics code here. And then the second one is to deploy the server. We should choose the environment, like it is the test environment or the formal environment, and we add the config to the server itself, and we will compile the code and deploy it via the dashboards of the TARS web, and we can start it by just click your mouse. Then the third step, we should develop the client who will call the server here. We can get the interface file TARS, which defined here, and to build the proxy class and create the proxy objective, and just have the one line to get IP ports by the object name, and then it can start the sync or async call here, and then it can receive and or use the callback function to get the result. So it's very easy to use TARS itself. We take an example here. This is the TARS file. Looks like we just mentioned more before. We can give another one here. This is one structure like the bind value. It's used to bind the mobile number and the QQ number here, and it has the interface of bind, and which have the function of query the bind QQ just to improve the mobile number here, and it will get the bind value just like the QQ number here, and then it will code the generation to use the TARS to CPP here to generate the basic tool here. These codes here in the client and in the server are both automatic generated by the tool. You just need to write this one in. These are always generated by the tool of TARS CPP. In these two pictures, you don't need to type any letters here. It has all the results here, and then you just focus on to write the write the code in these functions. That's okay. It has a quick introduction about the interfaces in TARS. The TARS has three parts of its naming rules. The first one, we can take the example of the common bind server bind here. The common is the application parts, and the bind server is the server parts, and the bind is the processing class parts. We have these three parts together. We can to make sure the only one endpoint and the function we need in the TARS system, and this is stand for an IP port too. And the create TARS service.sh is the generate script. It can help us to generate these files automatically, and in that we have all the basic codes here. And it can have several APIs in these files, like the initialize and destroy, and initialize the implement and destroy it, and the main function of query bind QQ here. And how to make the call. This is what we should type in that, but it's very easy for us to do it. It has two ways: sync here and async here. No, the three ways, and one is here. For the sync ways, we can use the function like at first we will create the communicate pointer to set the property like this is to set the registry which can call, and for that after that we can use this proxy to call the TARS bind server and bind objective that I mentioned before. And this is one line can make these name to the IP and port here, and then it will return in the proxy, and to use the proxy, the function of this proxy to query that this mobile number which QQ is bind with. Just 1, 2, 3, 4, 5. Just with 5 lines of code, we can achieve that goal. And for the async version here, we just to change the function to with the callback function, and to write some code here to achieve the same goal. And after that, here to here is like the similar. It's the similar like this sync mode. It will still use this tree to process to change this name to the IP and port, and it will use the callback pointer to call the query bind QQ interface, and the callback will return the value of the results. And this one, if we change this object to null, that means we don't need the return. That it will exactly change to the one-way call function, and it's very easy too. TARS has a very efficient service management dashboard. We call it TARS Web. It has a lot of functions like deploy the services. We can see that it has all the information of app, the application, the service name, and the type. It includes several developing languages and has the template configuration. And the node here is which IP you will use, and we can you can set the set mode here that I just mentioned before, and this is the information of the objective. It binds the endpoint IP and port, and which protocol it will use, like the TCP, UDP, and if it's a TARS protocol or a user definition, we can use that here, and others are basic information like the connection and the queue and timeout, something we can configuration here too. And then TARS has the option of expand server. It is very easy to use. Just to select the apps, the service, the set, and the node it will base on, and type the target IP here, and just with one click of function of button here, this server will expand to one or more machine server. Yeah. And this one is for the template configuration. Here we can see we have multiple kind of templates. Besides the default, it has the patch, the configuration, notify, the node, state, property, log, and Java or others here to face on different kind of TARS servers. And this is the interface of the TARS server after it's successful developed and running successful. We can see here has the node information is the IP here, and if it had the set and its status with the configuration status and the current status, we can see it's running well here. And this is the process ID and the code version or the release version, and when it's published, and several operation button here, and we can see lots of status information here, like if it's if this progress are going to the zombie, and it will automatically restart it by the framework. And for the server configuration that we just mentioned before, it has several levels here. And for the metric here, and we can see there includes several monitor information here, like the flow numbers and the average time here. We can choose the data which is start and the end, and the time and the start time and the end time. And if we are focused on which interface have some which interface will have problems, we can specify the interface name here, and or the master name here, master, which means the client here, and this is the server name here, and IP is always the same. We can see all the information that we want to make sure this server runs well or not. And this one is the property monitor. We can specify which one, specify several other monitor information that we are interested with, just like the the queue length or the memory take. Yeah, this is all the basic things I've introduced about the TARS framework, and I think maybe it will be the end of my speech. And thank you for listening. Thank you very much.